There are tens of thousands of gallons of gasoline sitting underground beneath your feet. Your fuel light is on. The station sign is glowing. The price board still shows numbers. The canopy lights might even be on, but the pump won't start. The screen is dark. The nozzle does nothing. Not because the station ran out of fuel, because it ran out of electricity. And that's the part almost nobody understands. During blackouts, gas stations shut down even when their underground tanks are full. People argue with attendants. They assume deliveries stopped. They think there's a shortage, but most of the time, the gasoline is still there. You just can't reach it. Modern gas stations are not storage facilities. They are electrically controlled access points. Beneath every station are large underground storage tanks holding anywhere from 10,000 to 40,000 gallons of fuel. But gasoline does not rise on its own. There is no gravity feed pushing it upward. There is no natural pressure system forcing it to the surface. Instead, inside those tanks are submersible turbine pumps powered entirely by electricity. When you squeeze the nozzle, you are not pulling fuel upward. You are sending a signal that activates an electric motor submerged in gasoline. That motor pressurizes the line and pushes fuel through a controlled system into your vehicle. No electricity means no motor. No motor means no flow. The gasoline is not gone. It is simply unreachable. And that mechanical dependency is only the beginning. Even if the pump could run, the station still couldn't legally sell you fuel without power. Every modern dispenser is integrated with digital flow meters that calculate volume down to tiny fractions of a gallon. The system updates pricing in real time. It communicates with payment processors to authorize credit cards. It logs transactions for accounting and compliance. It runs fraud detection protocols. If the power fails, the system cannot verify how much fuel was dispensed or whether payment was approved. No verification means no sale. Beyond payment, there is regulation. Gas stations are tightly controlled environments because fuel vapor is flammable and underground leaks are catastrophic. Electronic vapor recovery systems capture fumes. Leak detection sensors monitor tank pressure and integrity. Overfill protection systems prevent environmental damage. Emergency shutoff valves stand ready in case of malfunction. Many of these systems default to a locked state when electricity disappears. They are designed to fail safe. That means when power goes down, pumps are programmed not to activate. It is not a glitch, it is intentional. A station can sit on 30,000 gallons of gasoline with customers lined up outside and still be legally and mechanically incapable of dispensing a single drop. From the outside, it looks absurd. From the inside, it is precision engineering behaving exactly as designed. Safety and efficiency were prioritized. Manual override was not. Now widen the frame. Gasoline does not appear in those underground tanks by magic. It moves through a chain that begins at refineries, flows into pipelines, reaches distribution terminals, and then travels by tanker truck to retail stations. Every link in that chain depends on electricity. Pipelines rely on electrically powered pump stations to move fuel across hundreds or thousands of miles. Distribution terminals use powered loading racks to transfer fuel into tanker trucks. Those trucks rely on digital dispatch systems, routing software, and traffic coordination to reach their destinations efficiently. When a blackout affects a region, disruption travels upstream. A station might regain power within 12 hours, but if the terminal supplying it is still offline, no trucks are loading. If pipeline pump stations lose electricity, fuel flow slows or stops across entire corridors. Even if refineries continue producing fuel, the ability to move it becomes constrained. And while movement slows, behavior accelerates. Blackouts change demand instantly. The moment neighborhoods go dark, drivers don't just think about commuting. They think about generators. Portable generators run on gasoline. People rush to fill fuel cans to power refrigerators, medical devices, and heating systems. Vehicle traffic and generator demand collide at the same pumps. A station that normally sells 10,000 gallons per day may move that volume in a few hours. Once a few stations lose power and close, demand concentrates on the ones that remain open. Word spreads quickly. That station still has power. Lines stretch around the block. Tempers rise. Stations that would normally have days of supply drain in hours. This is substitution shock applied to fuel. When part of the system disappears, demand shifts sideways. The remaining capacity was never designed to handle the full load. It empties, and the cascade compounds. Traffic lights rely on electricity. When intersections go dark, congestion increases dramatically. Delivery trucks slow down, routes extend, drivers approach legal limits on driving hours. Dispatchers scramble to reroute around gridlocked areas. The same blackout that triggered the surge also delays the trucks attempting to resupply the open stations. Closed stations sit on fuel they cannot access because their pumps lack power. Open stations run dry because demand exceeded projections. Deliveries are delayed because infrastructure is unstable. Even after electricity returns, recovery is not instant. Stations that emptied during the surge are still empty. Tanker trucks are already committed to emergency routes. Distribution terminals prioritize high-volume corridors first. Smaller neighborhood stations may wait another day or two before being refilled. So, you get a second wave of frustration. The lights come back, the canopy glows, the pumps activate, but the underground tank is empty. The blackout lasted 8 hours. The fuel disruption lasts 48. From the outside, it feels chaotic and unfair. From the inside, it is mechanical and predictable. Modern gas stations are electric fuel access systems, not storage bunkers. They are optimized for efficiency, thin margins, and continuous infrastructure. Installing industrial-scale backup generators large enough to power pumps, payment systems, refrigeration, lighting, and safety controls is expensive and complex. For most operators, blackouts are rare and short, so they design for normal conditions. The system works beautifully when electricity flows. It fails quickly when it doesn't. The fuel underground was never the limiting factor, the grid was. Gas stations shut down during blackouts not because they ran out of gasoline, but because the entire chain that converts liquid fuel into usable motion depends on electricity at every stage. When the grid pauses, the pumps pause. When motion pauses in a just-in-time network, scarcity appears instantly, even when supply still exists. That is why you can stand 10 feet above tens of thousands of gallons of gasoline and not be able to buy a single drop. The fuel is still there. The infrastructure that moves it is not. And in modern systems, access matters more than inventory. Now you can see the machine behind the pump.